How's it going, everybody? Today we're going to be talking about linked lists in C++. So linked lists are probably one of the more basic or beginner data structures that you're going to be learning when studying C++, but it's good to have an understanding about how they work. Before we actually get into the coding of it, just talking about what a linked list is, here's a visual representation of one. um, they differ from arrays because they're not continuous memory. Whereas if you had an array, there it has actual indexes you can index. So if you knew you wanted to get to this element, you would just index 2 because of 0, 1, 2. So you'd be able to index like that. Whereas in a linked list, it's held together by pointers and just random dynamically allocated memory. So if you wanted to go through and go to the second to last element in an array, you could just go ahead and reference that. With a linked list, you're going to have to go through the entire list until you get to the second to the last index. So a linked list has some advantages and disadvantages. An advantage would be adding to the front of a linked list or removing from the front is, since it works linearly, it's going to happen pretty fast. Whereas if you want to insert to the end or delete from the end, you're going to have to iterate through that entire linked list to get to that. So those are some ups and downs. When we're looking at this picture of a linked list, you can kind of break it down into two main components. You have which right here would be called the node, and then you have the overall uh, structure of all the nodes together, that being the linked list. Whereas this little individual thing would be the node. The node is going to be pretty simple for this program. We're going to be using a struct. It's basically just going to be composed of two elements. We're going to have a variable data, and data is going to be whatever our linked list is holding. It could be strings, integers. If you were to build a bigger node class, you can fill it with like more elements and more things. But we're just going to be doing single variables. We'll be using strings. So data is just what it's going to be holding. Next is going to be a pointer of type node, what this actually is, to be able to point to another node in the list. So those are our only two variable types on our head or on our node. With our linked list itself, the only actual variable that our linked list is going to be composed of is the head. The head is just an index to keep track of the first node in the list. This way, you always have something to start at. When I said before you had to cycle through the entire list, if you didn't have a pointer to reference the beginning of your list, you would not be able to do that. So head has to stay to the first node in the list. If you were to insert a new node before head, this pointer needs to switch, or else this element is going to be forgotten from when you're cycling through your list. So the only variable for our linked list is going to be the head pointer, whereas the linked list class itself is just going to be composed of different functions on how this list will operate. If it's going to be sorted, adding, deleting, showing elements, that's what your linked list class is really going to be filled with. So just getting into all the code of this, we are going to start out, we're going to do some includes real quick. I said I'm going to be using a string, so I'll go ahead and include that, and iostream. We will be using namespace for this. Again, you don't have to. So since we have all that set up, we can go ahead and just begin by creating the node. So we're going to create a struct, and we're going to call it node. And like I said before, coming back to this picture, if this is our node, the only two variable types we're going to be using is what our data is, what we're holding, and a pointer of type node called next. So I'm going to go ahead and string data. So we're holding data of type string, and we're going to have a node pointer called next. Now you guys will see how next works if you're not really, or just this node pointer if you're not familiar with pointers, dereferencing, arrow functions. Basically, in our list, we're going to be able to call a pointer. We'll just say it's named pointer, and we'll be able to call next using an arrow function to be able to point this to another pointer, which would be another node. So we could take this node and do next, and then point that, close enough, and then point that to another node. Maybe this node is temp 0. So then we could, if this was temp, we could point it to temp 0 using the arrow functions. It's just a way of dereferencing pointers and what they're containing. So that's actually it for our node itself. Now we just have to build our linked list. Now I'll be using a class for this. You can use a struct if you want. You're just going to have your function are just going to look a little different. So I'll go ahead and just call this list, I guess. Don't know what I was doing right there. So public, private. Now, like I've said before, talking about linked lists, there's only one variable in our linked list, and that's our head. And our head is a pointer to a node, so that means it's going to be of type node. So I'm going to go ahead and node, and we're just going to call it head. So this will keep track of the first element in our linked list. Now after that, it's basically just functions from here on out, so we can kind of decide on what we want to do with our linked list. So I'm going to go ahead and write a constructor first because we need that. And what our constructor, we can do our program inline because it's just going to be a single line, and we're going to be setting head to null. And basically what this line is saying is if we're creating just a linked list right off the bat, we're going to be using like new. So we're allocating a new node. Now this node isn't pointing to anything, and what is it filled with? We don't know yet, so we're just going to fill it with null. After it's filled with null, we can go ahead and change the data variable if we want to, but we have to give it a starting value, so we're just starting out with null. Now we can do a couple functions. Begin, we'll just do a show, and we'll do a insert front. There's a couple different ways you can insert from a linked list. Obviously, what we're going to be doing is just inserting a new node that'll then point to what the head was originally, and then we're going to move the head to that new node because it's in front of that. You can also insert from the middle and insert from the end. So if your linked list was sorted, which we're not doing in this video, then that could all kind of be in one insert because it's sorting, so sometimes you're going to have to put it in the front and back, but we're just going to have separate functions for that as of now. So if you were inserting from the front, we need, what are we inserting? We're inserting a string, and we'll just call it name. So I'll go ahead and do the insert front first, and then we can go ahead and look at how this is going to work. So writing our class function, class name, insert front. So we're gonna need we're gonna be using new because we're using dynamic memory, and we're gonna be using pointers a lot in linked lists. So it's gonna start out with node pointer temporary. So we're creating a temporary node of new node. So we're grabbing from memory a new block, and we're creating a node from it. So then, since it's going to start out being null, that data again, this is where the arrow function comes in. It's going to be name. As you can see, this is where data comes from. So we're referencing our pointer's data using an arrow function. So then what we have to do after this, so now showing you guys what this looks like, we've basically created a node, gave it a name, just do NA, and that's all we've done so far. So now we're going to have to point it to something. So that's using next, our node pointer next. So dereferencing next equals head. So now what we've done in this line is we've taken this node and we've pointed it to the node that's being called head. After that, what we're simply going to do is reassign head to our temporary value. So now it's saying this isn't head anymore. Now this is head. So that's what that function does. It's hard to draw with this. So that's what that function does. So that's actually it. When we're doing our show function, this will kind of show us how we can traverse a list. So since we're going to be printing stuff out, I'm going to start it off with just a new line, just to free up some console space. It'll be easier because if we've just entered something and then your next line is printing things out, it can look a little jumbled. So this is again going to work with a pointer. So we're going to create a node pointer. We'll just call it temp, and then we're going to assign it to head. And then what we're going to say is, while that temporary pointer doesn't equal null, null being what the last element in our linked list is pointing to, then we're just going to cycle through. So it'll be temp equals temp next. But first, actually, we have to actually output. So we're going to output, we're going to reference the pointer we're on, its data, and then we're just going to print a new line, and then we have to move this pointer to the next spot in the list using next. So what we're doing is we're starting off at head, we're going to print this name out, and then we're going to go pointer equals pointer next. So then we take the pointer to the next one, print this data out, pointer equals pointer next, going to the next one until we hit null, and then we know we're finished. So that's how you can traverse an entire list and not miss anything and not get a segmentation fault. You'll probably get some segmentation faults when learning linked lists, just because if you're not on top of saving your memory, it can get a little out of hand. So now I'm going to go ahead and just create our list object. So I'll just call it linked list, and we're going to have a variable name. We're just going to create a quick loop to enter into our linked list. So now referencing our linked list class, it's going to be linked list dot insert front, and then our name, and then at the very end we will show our linked list. So that should be it if there was no errors. I'm going to go ahead and run this. So enter name, so I'll just go ahead. So I've entered 5 names, and then we've added all these to the front. So the front started off Alex, and then it goes Alex Susie, Sally, and so on and so forth. So this is us printing. Paul prints out first because it was the last to be added to the front of the list. So that's just simple inserting to the front and printing all of a linked list. So if you've got that down, you've understood that, we should be good to move on to just other methods. So our next function we're going to do is just an add, and this add function, it'll add nodes anywhere depending on the size. So it'll throw the new nodes into the end, or if it's not sized, it'll start off as a head. So this is just adding to the end like an append. So we're going to do the same thing. We're going to take a string name, and then so when doing this function, again, we're going to be using node pointers, and we're going to be creating a temporary, which is new node. It's going to start out pretty much the same as our last function. We need to create a new node, so that's how we do it. So, and then we're going to take that data and we're going to fill it with what was passed into the function. And then since we're adding to the end, if this is the last node, we need to recreate this. So we need a node that's pointing to null. So this new node that we've created next, which is what we're pointing to, we have to set that to null, because we're going to be, basically with this function, we're going to be traversing the list till we get to this one, and then instead of pointing to null, we're going to point it to a new node, and that node's going to be pointing to null. So it's just like inserting it into the end. So getting back on topic, there's a couple of base case tests you have to do. So test number one is depending on the size. So if head equals null, that basically just means the list is of size 1. It's just a singular node. Then we can go ahead and just assign that node to our temporary. So head equals our temporary. So it's going to take all the data from that. Else, what we have to do, this is just getting us, if it's not head, we're just getting to the last index in the list. So we're going to need another pointer insert, and we're going to assign this to head. And insert basically is just going to traverse the list until we get to the final node. So while insert next doesn't equal null, we're going to iterate that pointer. And then once we've gotten to the node's pointer equals null, so this one, we're going to take that and we're going to point that to our new node that we've created that's just kind of been up here chilling, waiting to be put in. And that node is already pointed to null. So we'll get rid of this by pointing it to a new node, which is already pointing to null. So once we have gotten to the last node, then it's just insert next, or what insert's pointing to is going to be temp. And that'll be it for our add function. So we'll go ahead and just show you what that looks like. So I'm going to go ahead and fill the list. I try to do it alphabetically so we can see but it's actually going to go backwards. Since these are all added to the front, it should go Ehrlich first, but then the next name we add should be the last name outputted, so it should be under Alex. So the last name, I'll just call it last. What about that? So boom, prints out all of it, and last is last because we've gotten all the way down to the last pointer and then assigned it. So that's how you would do insert just towards the end of it. I guess the last thing we should probably talk about would be removing a node from the list. So we're going to go ahead and create a remove function, and we're just going to be passing in a target string. So remove has kind of a couple more cases that you have to remember, but they're not terrible. So with our remove, the first step we have to do is see if the head is the target. That'll usually be the case with many linked list programs. Your functions are going to start out, what's head doing? Like what does this list look like? So if our head data is our target, we're going to go into this list. So step one will be check the head, and then we have to do one more check. So if head next equals null, then we know that this is a list of just size 1. So if this is a list of just size 1, then we can just say head equals null and wipe that single memory space. Else, what we're going to be doing is creating a node pointer. So dpt pointer, I'll call that for head, so that equals head. So now we've assigned, so what this case is saying is then if this is what we actually want to, if our head is what we actually want to remove, but we have a list longer, then what we can do is we can assign a pointer to the head, move the head to the next element in the list, and then delete the pointer that was once here. So that's what we're going to be doing. So where was I? Oh, right here. So we're creating a delete pointer and we're putting it on head. So our head is going to equal whatever is next in the list. So we're just going to take the pointer. Head equals head next. Then we can go ahead and delete our delete pointer. Make sure you delete your nodes that you're not using anymore, or you can eventually run out of memory. That's just one thing to make sure you're staying on top of. So next we're going to be, pretty much if we're not dealing with the head, is going to be our else statement. And the way that you have to go about deleting in a linked list, since you can't go backwards because pointers are only facing one direction, if this is the pointer that I want to delete, you have to have a pointer behind your pointer that's going through, because if this is the pointer I want to delete, then I can then, instead of this pointing here like it usually is, I can reassign this node's pointer to skip that that node and point to the next object, and then we can go ahead and delete this pointer using the pointer that's referencing it. So you're going to be using 2 pointers in singly linked lists. Doubly linked lists, there are ways to do it without that, but we're not doing a doubly linked list. So if not, we're going to have node cursor. This is going to be the one that's in the lead, the one that's checking the string values of every node that we're in. Then we're going to have a tail, and this is going to be, or I guess I'll call it trail. That'll make more sense. and it trails 1 behind our cursor. So getting into our list, we have already assigned our cursor to head, so we can kind of like our print all or our show all function, just while cursor next doesn't equal null, and we're just going to go through. So before we iterate cursor, we have to assign, so if this is cursor and this is trail, we have to move trail to cursor before we can move cursor on, or else we're just going to have them in the same area. So trail equals cursor, we're going to move to the next node, and then we're going to see. So if cursor's data equals our target, what we're looking for, make sure you use double equal sign. Well, what are we going to do if this happens? We're going to take our trail and point it to what's in front of cursor. And then we're just going to go ahead and delete cursor. And that's actually the end of this function. You could also, if you want to, just go out of this else statement and just type in name was not found or something, because the code won't get here unless it hasn't deleted something. But going off of that one more time, basically what happened was we started out, cursor was here, next loop through, trail equals where cursor was, cursor moved. This is what we want to delete. It's cursor data. So trail, what we're pointing to, becomes the next of cursor. So trail next equals cursor next, and then we deleted cursor. So that's how you can delete an element from a linked list. Yeah, and this works pretty much all around, except for head is when you have to change it. That's a special case, but that's how it works. So then I'll just go ahead and delete this, and I can change this around. So enter name to delete, and we'll do make sure what I named it, remove. So it's gonna look kind of ugly, but I'm just gonna paste it twice. You know, I'll paste it 3 times. We'll do that 3 times. And just to show off like the finalized bit, how everything works. So I'm gonna go ahead and clear the console. And we have an error on line 77. So let me go to that real quick. Typo. Head equals head next. Not, you can't have a pointer next of a pointer. So that should resolve the problems. So running the program, we're just gonna enter in some names: Alex, Sophia, Robbie. Enter a name to delete. So I'll start off with checking the head case. Since these are all insert front, Nick is going to be the head actually. So I'm going to enter Nick. So yeah, that was actually just printing that because I didn't use a return. Like, if that would work if I used a return statement like in my code right here for this void function and then printed it, but actually I was just cycling through all the code it would enter the else statement and hit the rest of the code in the function. So that's why it was saying name not found even when it was working. So just running this one more time to show you guys what it looks like. Okay, now enter name Alex, Brad. Enter name to delete. Delete Nick works. Robbie to delete. Sophia to delete. So basically, guys, yeah, that's how a linked list works. You can go far more in depth with functions if you want it to be sorted. Your node can be an entire class filled with a whole bunch of different data. So yeah, this is basically just the building blocks in getting the basics down of linked list. I might release another video showing a more advanced linked list. We could use templates inside of it. So yeah, if this is something you guys are interested in, let me know. I'll make sure to post the code in the comments below. Thanks for watching. If you have any questions, feel free to leave them in the comments. Yeah, that's about it.